So here we go. I think just like with the last couple of homeworks we've done, if you did it, I'm assuming you have the right answer because, well, these were straight off the reference table. So starting off with number 1, the bioclastic rocks are always limestone and bituminous coal. I've definitely checked on that, bituminous coal. And bioclastic rocks, they're classified by their composition. The rock composed of calcite is limestone. I think we talked about this one yesterday, but if not, number 4, the sedimentary rock that may bubble when HCl is placed on it. So HCl is acid. That will be limestone will bubble with acid because it's made out of nothing but calcite. So that one, you had to use 2 reference tables. And yes, that is, that's like their jam. The Regents people love making you use 2 reference tables. So you had to check to see what mineral bubbled with acid and then what sedimentary rock was made out of that mineral. That is what they love to do, checking out 2 reference tables with 1 question. Moving on, decayed plants, that is bituminous coal, composed of halite, is rock salt, composition of coal is carbon. Fragmental sedimentary rocks, they're classified on the basis of their grain size. Rock that contains angular fragments of mixed, why is this going in and out like that? Super annoying. Mixed and angular, that's going to be breccia or breccia, depending on how you want to say it. Number 10, 0.0004 to 0.006, that's siltstone. Shale is made of sediments that are less than 0.0004 centimeters. Make sure that if you're using the less than and greater than signs, that you know which one is which. Because if you do it wrong, I have to mark it wrong, even if that's not what you meant. What I was looking for number 12, that one messed up some people. Sandstone is made up of sand-sized particles with a grain size of 0.006 to 0.2. The 3 that are made from evaporated seawater, those are going to be the crystalline rocks, rock salt, rock gypsum, and dolostone. 14, organic remains, that's limestone and bituminous coal. Made of clay, that's going to be shale. And then we have pebbles, rounded pebbles, conglomerate. Shells and skeletons, that's limestone. Sand cemented together, sandstone. Made of gypsum is rock gypsum. Made of dolomite is dolostone. Is coal crystalline or bioclastic? It is bioclastic. Conglomerate, that's going to be inorganic, and gypsum is crystalline. Down there at 24, sedimentary rocks are made on the surface. And explain why. So I said that's where the sediments are. So sediments are made of broken pieces of rocks, and all the things that can break rocks are on the surface. Number 25, this actually asked you to go back to something we haven't talked about. So did a bunch of you skip 25? No, you guys all did it. Is that what you got? Okay, so first of all, it does say rock type. No. Okay. Okay, so here's where you went wrong when you put just limestone. When they say what rock type, you get 3 choices for type: igneous, sedimentary, metamorphic. So they were asking what's most popular, igneous, sedimentary, and metamorphic on page 3 of your reference table. Now we have looked at page 3 and I have asked you to kind of ignore everything except for the map itself up until right now. So I don't know if you even happen to notice this, but the title is Generalized Bedrock Geology of New York State. So this is all the bedrock that's here in New York State. Again, we've talked about what bedrock is. If you were to dig a hole outside, just like in Minecraft, if you dig down, you're eventually going to hit a solid layer of rock that you can't just dig through. You would have to use drills or dynamite or something to get through it. Again, just like in Minecraft, I believe, right? No, you can't break. Okay, so I've never actually played Minecraft. I'm just making assumptions based on what people have told me. You can't even dynamite your way through bedrock? Okay, see, there are certain methods. Just like in real life, you can get through it, but it doesn't, a shovel or a backhoe is not gonna do it. But anyway, bedrock is the rock that was born and raised here, never moved. You can't move a giant bed of rock. It's too heavy. It's too large. It goes, like, there is rock that is underneath our entire school that's just one solid rock. It's way down deep, but there is rocks that are just, that's why it's called bedrocks. It's a giant bed of rock. So these rocks haven't moved. They were born here, lived here, haven't been moved anywhere. So you can see the different symbols here, and they match up with the symbols down here. So us in this area, we're these polka dots. So these are polka dots. Now it does tell you the geological period and eras in New York. We haven't learned that yet. It's chapter 6, but that's basically telling you when they were made. But if you look, then it tells you what those are. So Devonian, which is us, is limestone, shale, sandstones, conglomerate. Silurian also contains rock, salt, gypsum, and hematite. Which you might realize those are all sedimentary rocks, or you go over here and you say they are dominantly sedimentary origin. These group here are dominantly metamorphic rocks, and these are intensely metamorphic. But if you look for most of New York State, you see these stripes, diagonal stripes, polka dots, and more diagonal stripes. Yes, up here we've got some squiggles and some other things going on, but most of those rocks, polka dots, stripes, diagonal stripes, other diagonal stripes, they are all in the sedimentary column, or group, I should say. So that was a long explanation to say that that answer is sedimentary. And then finally, 25, why are fossils only found in sedimentary rock? I go with why they're not found in the other rocks. I always say that the formation of other rock types would destroy a fossil. And then finally, just to sum it up, how do sedimentary rocks form? They form when sediments get deposited, buried, and compacted and cemented together. Any questions on that page? Okay. So this page is just getting you familiar with the reference table, just kind of making sure you've seen it, you know how to read it. Your homework tonight is pages 28 and 29. It's the next 2 pages. You'll see that those are all Regents questions about sedimentary rocks. So that's taking it to the next step. Okay, you can do my questions, which are pretty easy and straightforward, but can you read the weird Regents questions and answer questions about sedimentary rocks that the Regents are going to ask you? But in the meantime, we are going to move on to the third and final rock chart, and that is the metamorphic rock chart. So this is it. We are getting close to the end of this chapter. We are either going to have a test on Friday or Monday. I know a lot of you are probably not showing up on Monday. Am I correct in my assumption there? We do not have school on Tuesday.
Yes.
You do have school on Monday. Elementary does not have school on Monday. Okay, so you guys, I know my kids always argue about this too. You may want to be an elementary kid today, but do you guys remember Regents Week in January and Regents Week in June? Okay, you really end up lucking out for the last-ish week of January when we give Regents. And again, I think you only come to school Monday. It might be Monday and Tuesday. I'm not positive. I think it's just Monday. And then you have a week off in January. Huh? There is no nap time. But lots of people still deal with their naps on their own then. Okay. I don't know the Heimlich. Do you need me? Yeah, I don't know the Heimlich, so I have to go find somebody who does.
Aren't you guys?
No, teachers are not trained. You guys are, we are not. But anyway, moving on. So Yes, it'll all work out in the wash. There's that saying again. So they don't have school on Monday and Tuesday. You don't have school back in January or the end of June. Yeah, you don't have school on Tuesday. But I do think the test is going to end up being on Monday. If you don't come, I don't care. You can make it up the next Monday. It's not a big deal. So that we'll see. We'll see where all my classes end up. But anyway, let's get on with this last rock chart. Oh, I guess I have to open it first. Hang on. What? Tuesday is parent-teacher conferences. All right, so once again, oh, gotta put this so that. Is everybody okay? All right, just like the last 2, 3 rock charts or whatever we've been looking at. Here's the metamorphic rock chart. It's another dichotomous key, arranged slightly different with slightly different information on it. But honestly, at this point, you guys should be pretty darn good at reading these. What is the way, according to this reference table, that we're going to separate metamorphic rocks? So if I handed you 20 metamorphic rocks, what groups are we putting them in according to this reference table? What's the first characteristic we care about? Texture. Yes, we have 2 choices for texture, foliated and non-foliated. Anyone have any idea what those words mean? Huh? It's foliated. This time I'm sure about it. Were you here? Say it. Say it. I was talking. Full, okay. That's not it, but it's pretty much close. They must have the same root word. I know nothing about like words, but they definitely sound very similar. I hear the word fold in that. Do you? Foliated, fold, maybe. Okay, we'll hear it now, would you? Here's when you take a piece of paper or laundry and you start folding it. What am I making on this sheet of paper? I am making folds. But I took one flat piece of paper and made lots of layers of paper. Will you buy that? Yeah. Well, that's what foliated rocks have, layers. So I don't know if that's actually the root word of the word foliated, but it certainly works for me. So foliated, once again, texture does not mean how it feels. Texture means how it looks. Get used to it. Foliated means the minerals are arranged in layers. Just like when I fold a piece of paper, I make a bunch of layers. Huh? But you'll see that foliated immediately gets broken up into 2 types of foliated. So basically 2 types of layers. One is mineral alignment and the other is banding. Banding is a nice, easy one to think of. It's bands of alternating colors. None of these are labeled. Oh no. No worries. No worries, everyone. So banding has alternating layers of color. Let me show you one of these. Here is a metamorphic rock with layers? It has banding. Why do you think they call it banding? It looks like there's bands. This looks like a black rubber band or a band going around the rock, a white band, and then a pink band, and so on and so forth. So when you see these zebra stripes, this is your dead giveaway of what kind of rock this is. So metamorphic rocks have layers in them. They have bands of color. So this is banding, easiest one. Mineral alignment is not as easy to see. And in fact, this one can be a little tricky. Let me see if I can find a good example. So this one, you don't see any stripes, and maybe I have to pass it around. Oh, right there is a good example of it. I'll pass it around so you can see better. But you can see distinct layers, except for these layers are all the same color. So mineral alignment, unlike banding, there's not any different colors, but there are still layers. So I say the minerals are lined up, alignment, lined up. They are the same color though. So I'll pass this around and you can see if you can see the layers in that rock. And I'm assuming, what do you think non-foliated rocks are? They're not foliated. They have no layers. You don't like that, Cam? Sorry. Oh, sorry. So you do have to remember what those three, I guess technically 4 words mean. Foliated layers, banding, alternating layers of color, mineral alignment, minerals are just lined up in layers, and then non-foliated, no layers. Grain size, just like we've been dealing with grain size this whole time, it's just how big the crystals are. Again, if you're looking for an exact size for these names, you're going to check out page 6 of your reference table with the igneous rock chart. So when they say fine, we go to the igneous rock chart and see that, remember that fine means the crystals are less than 1 millimeter. Coarse, they're bigger than 1 millimeter, smaller than 10. But as you can see, it doesn't really matter. Grain size for metamorphic rocks is useless for the most part. Yes, slate is only made of fine rocks or fine crystals, but like phyllite and this mineral schist, this is my favorite, they have fine to medium crystals. No, it's a piece of schist. Here is a piece of schist right here. One of my favorite rocks, because who doesn't like to say piece of schist in the middle of class? That one is the layered mineral alignment one. That is actually slate. This one that has stripes. We'll get to that. We'll move on. I digress. Now, once again, we've got the column for composition. You guys know that composition is what the rock is made out of. So down at the bottom, I'm jumping all over the place. Composition is what the rock is made out of. And some of them are super easy to tell what the rock is made out of. For example, anthracite coal. Only thing it's made out of is carbon. Hornsfeld, it's made out of various minerals. Quartzite, what do you know is made out of quartz? Marble is made out of calcite and or dolomite, metaconglomerate, various minerals. It gets a little weird at the top though. Do you think you guys can figure out how that top chart works for composition? Take a look at the composition column on the top half of this chart for the foliated rock. Kind of. So basically how this works is if the bar is in the box for that rock, then it has that mineral in it. For example, slate, you'll read over and you see that there is only one bar in the box slate and it is labeled mica. What do you think slate is made out of? Sorry, just mica, only mica. But if we go down to this phyllite, you'll see that it's got the bar for mica, so it's got mica in it, but the bar for quartzite or quartz is there. So it's feldspar, amphibole, and garnet. Pyroxene does not go up that high, so phyllite has no pyroxene in it. That piece of schist I'm holding, though, it might have pyroxene in it, but some of it doesn't. So some schist has pyrite, some schist does not have pyrite. But this guy right here, anybody have any idea how to say this one? Nice. Okay, this is nice, not gneiss, just nice. Has all of those minerals in it. So this is nice and this is a piece of shit. Come on, guys, you gotta laugh at that one. The nice piece of shit. Don't take me for granted next time. It's not funny if I have to explain it. Shut up, Cam, it was too. Whatever. Type of Thanks, TJ. Thanks. Types of metamorphism. You can see that there's only two different types: regional and contact. What do you think regional means? In a region, the whole area. So for regional metamorphism, it affects a whole region, like the entire area. High temperature and pressures affect a large area. When do you think there is enough heat and what do you think creates enough heat and pressure to affect a large area? Mountains. That's it. Mountain building. You guys know the basics of how mountains are built, right? What happens to make a mountain? Yeah, the tectonic plates. Two giant plates the size of a continent run into each other. We're going to, by the way, next chapter, learn how and why that happens. But two plates come together. They push so hard that they're able to push up a giant mountain. If the earth can push up a mountain range, imagine how much pressure that has. If there is enough pressure to pop up a mountain, that's a lot of pressure. So that's when metamorphism affects a whole region. Contact is different. That's going to be a small area that gets contacted by heat and pressure and just produces contact metamorphism on the rocks it's touching. So it won't be a whole region. Hot lava touches a rock, it heats it up enough to change it, but not enough to melt it. I'm gonna put rock name up there because, well, oh no, I'm not. I guess I'm going down to comments. Comments, I say, has some extra stuff to help you identify the rock or tells you the rock it came from. Let me explain what that means. So some of the extra stuff, like up here at the top. Oh wait, no, not that one. Never mind. So some of the extra stuff is here at phyllite. Foliation surfaces shiny with microscopic mica crystals. Or schist, clady mica crystals with visible from metamorphism of clay or feldspar. Nice, high-grade metamorphism, mineral type segregated into bands. So that's the extra stuff I'm talking about. But then also some of them, like slate, say it's a low-grade metamorphism of shale. That's what's called identifying the parent rock. Now here's why it's called parent rock. Where did you guys come from? Your parents. So, again, I know this is not biology. I'm not getting into details. Please just know you came from your parents. So that's what this is talking about. Here where it says slate, it tells you who its parent is. Because in this column, it tells you it's a low-grade metamorphism of shale. What that's saying is shale gives birth, in quotes, to slate when it gets a low-grade metamorphism. That means just a little bit of heat and pressure. If you go down here to like anthracite coal, you'll see it's a metamorphism of bituminous coal. Again, that means that bituminous coal is the parent of anthracite coal. So it's telling you who it used to be before it got heat and pressure. Again, quartzite is a metamorphism of quartz sandstone. So if I take sandstone, give it heat and pressure, it'll give birth to quartzite. Same with marble, metamorphism of limestone or dolostone. All right, finally, the last two. Rock name, the name of the metamorphic rock. I know. And then I did give you a box for map symbol this time, but again, we're not going to be talking about this until chapter 6. On the regions, they'll always use this symbol to identify the rock on a map. I'll show you what those maps look like tomorrow just so you see them, but we won't be dealing with them until chapter 6. All right, when you are done, I am going to leave metamorphic rocks off here. So you have about 10 minutes until class is over. You are welcome to go ahead and get a head start on your homework. There are 19, I think, Regents questions. So again, a little bit more than I would usually assign. That's why I'm giving you time now, but I want you to really put in the effort. Look up your answers, try hard. Don't just guess, don't just circle answers. If you need help, call me over. But that's it for today. I'm thinking the test, I may try to get it in on Friday, but I'm not sure that's going to be possible. I'll let you know tomorrow.